good morning, good afternoon, good evening, depending on the location you are watching from. My name is Mwansa Kitochukwu Peter. I'm glad to start this wonderful journey with you. So in this channel, we'll be learning statistics together and the use of statistical packages such as R, MATLAB, SPSS, Minitab, and Stata to compose some statistical analysis. So in statistics, we have two branches: descriptive statistics and inferential statistics. But in this channel, we're focusing on what? Inferential statistics, because that is the area most people find it more difficult. So we are going to start with what? Probability, the elementary probability. So probability, when we talk about probability just a measure of what? The likelihood of occurrence of what? An event. So, but before we go into the probability definition proper, we are going to define some important terms, like one or two important terms. Now, number one is what? Random experiment. An experiment is said to be what? An experiment is said to be random if its outcome cannot be predicted with certainty prior to the what? Performance of the experiment. What did I say? An experiment is said to be random if its outcome cannot be predicted prior to the performance of what? That experiment. For example, if a coin is tossed, one is not certain that it is head that will appear first or a tail. So in that particular experiment, it is a random experiment because its outcome cannot what? Be predicted. Now we are going to look at what they call a sample space. A sample space is denoted as with what? Capital S or ohm. Denoted with what? Capital S or ohm. It is called the collection of what? All the possible outcome of an experiment. What did I say? A sample space is the collection of all possible outcome of an experiment. If a coin is tossed twice, this is the first toss. We have head and tail. Second toss have head, tail. So this will give you head, tail, head, tail. So we have four possible outcomes. So, and these four possible outcomes is what we call a sample space. And each of these particular outcome is called an event. What did I say? Each of these particular outcome is called what? An event. Now let's go in statistics. Probability is interpreted in three different ways or perspective. Number one, we are going to look at what? Classical definition of probability. Classical definition of probability. What did I say? In statistics, probability is interpreted in three different what? Perspective. Number one is what? Classical definition of probability. So in classical definition of probability, suppose an event E can happen in N of E out of n possible ways, then the probability of an event E occurring is given by probability of what? E, which is equal to what? N of E all over what? Capital N. And the probability of what? Event E not happening, the probability of event E not happening is equal to what? 1 minus what? Probability of event E happening, which is equal to what? 1 minus N of what? E all over what? N. Now let's solve an example. Let's solve an example. In a toss of a die, if a die, example 1, if a die is tossed once, what is the probability of obtaining 4? Solution. First of all, you know, in a toss of a die, we have 6 possible outcomes, which means there was sample space ranges from what? The sample space S is equal to 1, 2, 3, 4, 5, 6. And the probability of obtaining each of every these possible outcomes is what? 1 over what? 6. Probability of obtaining 1 is equal to what? 1 over what? 6. Probability of obtaining 2 is equal to 1 over what? 6. The probability of what? Obtaining 6, which is equal to what? 1 over 6. But the question says, what is the probability of obtaining 4? And in this place, 4 is what? Our event we are interested in. So the probability of obtaining 4 is equal to what? How many 4 do we have here? Is 1 out of 6 outcomes that we have, which will give us what? 1 over what? 6. So this is what the classical definitions of probability. Now we are going to look at what? Another aspect of this probability called relative frequency distribution, relative frequency definitions of probability, or you call it empirical definitions of probability. Relative frequency definition. So the second one is what? The relative frequency distribution. What did I say? Relative frequency distribution. So let's begin. If an experiment is performed n times, and a particular attribute or event occurs r times. Now the probability of event okay. So if an experiment is performed n times and a particular attribute or event A occurs r times, now the probability of this event A occurring is equal to what? R over what? N. So let's solve an example. Example 2. If an experiment, if a coin is tossed 100 times and head appears 54 times, what is the probability of obtaining head? So the question says, if a coin is tossed 100 times and a head appears 54 times, what is the probability of obtaining head? Solution. We have our n to be equal to what? 100, and r is equal to what? 54. And we have our event to be what? Head, which is equal to what? 54. So the probability
like you need to take the time. Water. Okay. Take time. Or good more good self now. If the thing no reach that 15 minutes, you go start fresh. Don't worry, later you go cut this side while they talk like this out.
Okay.
Yeah. But I'll quote you with so that you can happy of hair.
So
very sharp.
So the probability of obtaining an event A is called what? Or let's say let A be an event of obtaining head. So the probability of what? A is equal to what? Is equal to 54 all over what? 100, which is equal to 0.54. That will lead us to what? Number 3, which is axiomatic definition of probability. What did I say? Axiomatic definitions of what? Probability. Axiomatic definition of probability. Axiomatic definition of probability. Axiomatic definition of probability. axiomatic definition. Okay.